We're gonna get there. Okay, this is work. No, it does not. Yeah. See. There we go. Perfect. Okay. So, kicking things off here. Perfect. So, welcome to the Communities in CNCF hosting the meetup together with Google as well as Google Cloud Meetup. So, very happy to see all of you here joining us. We have a great program coming up. Erno, who you saw probably downstairs from the Google side, is going to come say hi at some point to the stage, but he's there busy letting people in, so we're going to let him do that. Understandable, yes. I'm glad that everyone got some food. You can obviously grab some food or drinks throughout the program and whatnot, so just enjoy and so forth. Then, let's see if this still works. Yes. Okay, it's a bit blurry, but let's not worry. Nice rhyming here as well. So we have, now we're in the intro portion, so we're just gonna say hi here with organizers. So hello, hello. If you want to say hi, or we have Mariam and Lucas here, so that's good. And then we have the Cloud Native Con plus KubeCon recap by Mariam here coming up, and after that we have my session, which is sustainability and Kubernetes, why and how, essentially an intro to sustainable development and sustainable Kubernetes as well. And then we have a really great session coming up from Nicholas Peak, who's sitting there. After that, and then we have the Google I/O stream watch after that. So a lot of program, very packed, very excited for all of this. And now that we're kicking off, we are here, and the CNCF and Kubernetes meetup is not alone per se, because we are part of Cloud Native Nordics, which is a Nordic-wide loose organization organizing all of these kind of amazing meetups across the Nordics. So we are part of a bigger picture. You can see here all of the different meetups that we know of. There's always new ones popping up, so that's always lively to see. And we have so many things happening, which is really great. Okay, so there should be the Google Cloud Network here, but it's fine. Erno is gonna talk about that later. And as mentioned before, it is not only us, there's all of these lovely people, for example, involved in the organization, so no worries there. Then we have welcome new members. Who here is at a CNCF or Google meetup for the first time? Oh, that's a good amount, perfect. Good, we always want first timers, that's always great to see. Welcome, and remember, join in the future as well. Then join the community. So we have, in addition to the meetup group that you joined, likely because you need to join before you're going to attend an event, we have, for example, the Slack channel, we have the website, we have a YouTube channel, so you can check all of those out and join the fun there as well, see recordings of past meetups and so forth. Then what's up next? We are always looking for new speakers. So if you are even inkling in your mind thinking, ooh, I want to share something, I want to teach something, reach out to us and we'll get you started. So even if you have just an idea, a user story or something, we're happy to give you the platform to talk to people about it, teach about it, and for example, share what you succeeded and what you failed at. So that's always lovely to see. Then, we have a welcome to new co-organizers. Yeah, Lucas made the slide, so that's why I'm kind of surprised by every slide that I see. Okay, so Mariam, welcome. Thank you for joining in. Yes. And if anyone else obviously wants to help organize these events, come and talk to us as well. Then, the history, there's a bit of history here. So Cloud Native Computing Foundation, as you can see here, was established in 2015. So this has been a bit of time in coming. And the CNCF plans to create and drive an adoption of new set of common container technologies, driven and informed by technical merit and end user value that is inspired by internet scale computing. And CNCF also seeks to improve the overall developer experience, paving the way for faster code reviews, improved machine efficiency, reduced cost, and increases in the overall agility and maintainability of applications. a very noble mission, a very good mission, which is bringing us here. So today, CNCF has over 700 members. You can see a portion, I think, of the cloud native landscape here. And it is a massive impact into the world. So you can see there some market cap and funding numbers. So it is quite big. And now this is a bigger view of the cloud native landscape. And if you are seeing it this for the first time, is anyone actually seeing it for the first time? Raise your hand. Okay, few people. Well, for you, it's a lot, like for sure. And honestly, for me, even if I'm seeing it for the 100th time, it's a lot. So no worries if it seems confusing. You only can really use it if you actually zoom into a certain part of it. So if it seems overwhelming, that's actually the normal response. But there's a lot going on. And easier way to look at it is that all CNCF projects can be characterized into different maturity levels. So it starts from the sandbox, and then it moves to the incubating phase, and then to the graduated phase. So there's all of these ways that we can easier approach the landscape, which in itself is a bit of a monster document. And here is some graduated projects and incubating projects that you can all explore more. If you want a simplified view into the cloud native ecosystem, you can check out the cloud native trail map, which is the map that you see here. So it starts from like containerization, CI/CD, and so forth. So you can kind of have an easier way to approach the ecosystem. And then we have cloud native definition here as well, which is cloud native technologies empower organizations to build and run scalable applications in modern dynamic environments such as public, private, and hybrid clouds. Container service meshes, microservices, immutable infrastructure, and declarative APIs exemplify this approach. These techniques enable loosely coupled systems that are resilient, manageable, and observable. Combined with robust automation, they allow engineers to make high-impact changes frequently and predictably with minimal toil. And just as a note, the cloud native requires a new mindset to work with, and you really need to kind of shift your paradigm a bit and think about it. We have these great events, which are the bigger events. So these are like the small local events. You have also the KubeCon and Cloud Native Con, which is the larger one. So the Europe just happened, which is what Mariam is giving up as a recap of it soon. And you can join us in the future as well. There is online programs as well from CNCF. So there's, for example, Cloud Native Live, which happens every Wednesday in about an hour. I've been hosting Cloud Native Live for about 2 years now or so. Join in there as well. It's strictly demos only, no like slideshows or anything, so it's a lot of fun. And then transparency report comes out as well. So there's a lot of interesting things that you can check out in the future. You can do certifications with CNCF as well. And now we're going to the KubeCon recap. Hopefully you're going to enjoy that after this super quick, a bit maybe confusing, but super quick intro into all things cloud native meetups. Yeah. Oh, you need to like push here. Oh. Always some excitement, this one. Yes. A little heart attack there. Yeah, you can just use those.
All right. Hello. I hope you've had a great day for now. Let's make it even better. Maybe some background and introduction about myself. My name is Mariam Tavakkoli. I'm originally from Iran. I moved to Finland in 2017 to pursue my master's studies. And I did a double degree in Aalto University and TU Delft in the Netherlands. And I was, after doing all my credits and student projects, I was still confused about my future career path. And however, that confusion gave me opportunity to choose. So I was lucky that I found my thesis position in Nokia Bell Labs. I was working on an application which was IoT publish subscribe application. And I looked around, I came across Dockerization, Kubernetes as hot topics of the day. So luckily those were also interesting topics for me. And I stayed on Kubernetes for the next 10 months until I did my master's thesis. And that was my start of my journey with Kubernetes. After that, after graduation, I started as a site reliability engineer at Relax Solutions. I'm currently a senior cloud engineer at the same company. So yeah, my story hasn't finished yet. How I ended up participating at KubeCon. I applied for the diversity scholarship, and well, working and studying as a woman in tech, I was always feeling isolated. This feeling of isolation wasn't really pleasant, and it was strong. So I had always this concept of inclusion and diversity in mind, and I really respected those places that were providing some opportunities and support for diversity and inclusion. However, I was probably shy to talk about it or act upon it, and the feeling of shyness probably was coming from the thought that maybe I'm receiving some benefits for granted, and I didn't want that. But coming along my career path and finding expertise in the field and finding more confidence, gave me the courage to look at the diversity and inclusion from a different perspective. I thought that differences should be celebrated, and as long as society is providing some support and opportunities for diversity and inclusion, people in a minority like me as a woman in tech should also act and show up and be involved more and grab these opportunities. So I saw the opportunity for this diversity scholarship to participate at KubeCon. I grabbed it, I applied, and luckily my application was accepted, and I ended up participating at KubeCon. I have still more on the topic of diversity and inclusion. Since I had these topics in mind when I participated at KubeCon, this talk from Dan Foster, director of open source community in VMware, caught my eyes. The title of talk was Building a Sustainable CNCF Project Contributor Base, and in that talk, Don mentioned about equality versus equity, meaning that, and she was emphasizing that in a society we need to provide not only equality but also equity, meaning that providing each person has different circumstances, different requirements, and we need to provide these requirements for different people in different levels so that everyone can reach to an equal outcome. So yeah, I think the topic was important, and it was interesting for me. Some more technical talks. What were the hot topics at KubeCon? Well, these were my observations, of course, but the first thing was service mesh, of course. Apart from day 0, which at first I thought it's day 1, but it wasn't, because it isn't an official part of the program. It's allocated to the co-hosted events, and there were, for example, Linkerd Day, Istio Day, CiliumCon, and all of these were hosted by CNCF. There were lots of talks about service mesh there, but apart from that, in the official part of the program, the next 3 days, there were also many talks with the topic of service mesh. And the most debate that was happening between audiences and people and end users was about the traditional model of service mesh, which is a sidecar model, versus the new model that, for example, Cilium offers, which is based on eBPF, a new technology which uses kernel programming. And yeah, the debate was there. Cilium was hype, and I didn't attend too much talks about Istio, but Istio was also offering their sidecarless ambient mesh, and yeah, overall service mesh was a huge topic. The next thing was security. I guess security has always been an important topic, and this year was like an exception. I didn't attend too much talks about security, but two of those that I attended, I saw one common slide in both presentations, which were from different people. And it was interesting for me, which was because it was the common slide. And it was about OWASP, which stands for Open Worldwide Application Security Project. And it introduces the top 10 risks in the area of Kubernetes. And the first three, for example, are insecure workload configuration, supply chain vulnerabilities, and overly permissive RBAC configurations. And I guess most of security talks were around these topics. So go and check out their website and see the whole list of 10 top security lists. These are only the first three ones. The next hot topic was about sustainability. One talk got my attention. The title of talk was Building a Sustainable Carbon-Aware Cloud. And in that talk, the presenter mentioned a project which is Carbon-Aware KEDA Operator project. KEDA itself is a Kubernetes event-driven autoscaler. And this Carbon-Aware KEDA Operator project is a Kubernetes operator that aims at reducing carbon emission by helping KEDA scale Kubernetes workloads based on the carbon intensity. So it's a cool project. Go to their website and check it out. Annie will talk more about sustainability so I won't say more. And the last topic was platform engineering. I guess it's the new topic which is involved on top of SRE and DevOps. And it's all around building an internal platform for developers so that they can concentrate on their development tasks and all other layers of infrastructure, GitOps, Kubernetes, and so on, is built for them through this platform engineering. One more thing that I would like to mention is communities in blooming, which was sort of a slogan in this KubeCon. You could see it everywhere. And it was actually my experience as well. I went to KubeCon thinking that the most part of experience would be about attending the talks and getting technical information. However, the most fun part and the most interesting and mind-blowing part was about how people are connected to each other, how they share their information, how they learn from each other. And I really enjoyed my talks with different people. I learned a lot. I got lots of information that I couldn't probably find surfing through internet, or either it has been impossible or it was taking too much from me. The evidence is here. Like, I had a lovely conversation with Lucas and Annie, and I met them there. Today I ended up here talking for you about my experience. So. Yeah, and I would like also to mention a great talk about gardens and glaciers saving knowledge through succession, which Emily Fox presented at KubeCon, and one sentence caught my mind: leave it better than you found it. And I really felt it at KubeCon with the community, that everyone was helping others to learn something and to do knowledge sharing. The last thing that I want to mention are some tips if you ended up participating at KubeCon in future. If I had these tips, it would probably maximize my experience. So one thing was that the keynotes were getting full quite soon, and after that they needed to close the doors. And if you want to be there, be on time and be quick. The same thing happened with the talks in the rooms, and people were saying that it happened only this year, but I think with 10 plus participants this year and probably also in future, it might happen also later in future. So that if you want to attend the talk, be sure to be a bit earlier at the room, otherwise you would miss the talk. One more tip is that there were some gatherings, diversity gatherings, there was a breakfast and a lunch, for example, in different days. Luckily, I was able to attend the lunch diversity, and there was a cool environment sitting at the table with a few people. So it was a really nice opportunity for me as an introvert, for example, to be with some people, have a safe environment to start talking, and we had a lovely conversation with those few number of people. Yeah, so if there was some this sort of opportunity at KubeCon, definitely I recommend it. I think that was my last slide. And thank you.
Thank you very much. Perfect. Thank you very much. So let's. I just wanted to mention that there are documentaries available about the different projects. I made this kind of very poorly looking list here, but there is one for Kubernetes, one for Prometheus, and one from Envoy. So I recommend checking these out, which kind of tells a little bit deeper behind the scenes of these projects, kind of telling personal stories from the founders and so forth on how some of these projects came to be. Thanks Marian very much for the recap. Then just for the next one is coming up in Chicago in early November, and I recommend that you book your tickets well, as soon as possible. At least I got surprised by them selling out this year, so it was this close that I wouldn't have had time to get the ticket. And it was 10,000 now in Amsterdam. I think it was 12, something like that, 1,000 in Chicago planned for. So we'll have a big conference there as well. And also with all the flights and hotels and stuff, it makes sense to be on time with that. Then if you can't go all the way to the US, there is also in Paris next March, and I think it was middle March. Well, that tickets haven't started selling yet, but keep an eye out for that. Well, then also I encourage everybody to kind of, if you're doing the same thing as for kind of speaking at these meetups, if you're doing anything related to these topics, we would be more than glad to kind of hear you share these stories. And same thing for KubeCon, if you're doing something interesting with different projects or taking them into use in various contexts, it really kind of can pay off to kind of submit a talk to KubeCon or, well, dry run them here, whatever, whichever way you like. So that is kind of a good way of sharing information, just like we discussed here. But yeah, that's for the first part of intro. Then I would like to get Erno and Nico here for the other, hello from the GDG, yeah.
Yeah, hello from the Google developer groups also. We're down there waiting for the door, so most of the people here actually have met me already. And here's my colleague Nico from Elisa.
Hello.
None a few words. So welcome everyone here. First we will have a CNCF talks in here, and the Google I/O live stream starts at 8 o'clock this evening. We will get some popcorn, so I hope to see most of the people here also for the later event. But enjoy the show.
I will use a couple of more words. So we are looking for new organizers for the GDG Helsinki. So if you're interested, let me know and come talk to me during the evening. Thanks.
And then now we will have a break. I don't know, maybe.
I don't think we have.
Or are you in a hurry?
No,
Yeah.
it's fine. 5 minutes.
Yeah, 5-10 minutes just for us to set up the AV for next year. Yeah.
Sitä on verhoilla.
Just wanted to make sure that you have
Yeah,
some time
I
to-
set up already, so everything is
Oh,
ready. That's why I was like, no need, no need. But if everyone wants to visit like bathroom, whatever, it's fine. Okay, that's good. Okay, so hello from me again. I'm back. I might be drinking a bit more water than usual because I don't know if you can tell, but my voice is kind of disappearing. Too much karaoke over the weekend. I blame that. Bad choice or a good choice, depending on how you think about it. But let's go. So who am I? I was here babbling on a bit earlier, but I'm Annie. Nice to see you all. I am a CMO at Vision. So Vision is a managed Kubernetes and OpenShift company that supports open source quite widely as well. For example, with a sandbox project for CNCF and so forth. And I lead the marketing there. I'm also a CNCF ambassador as well as an Azure MVP. And what those two mean essentially is just that I am way too happy to speak and teach and think about Kubernetes and the cloud in general. So I'm very happy to be here today. I'm also a Kubernetes and CNCF meetup co-organizer. You might have figured that out since I was here in the intro session, but just to clarify, I also coach early stage startups as well as co-host Cloud Gossip podcast. I've also been hosting the Cloud Native Live, the Wednesday live stream by CNCF a while, as well as I mentioned before, as well as I'm frequently in the KubeCon plus Cloud Native Con program committee. I was a track chair in the last Eurocon, so if anyone wants to have like any help with CFPs or anything, super happy to help with that as well. But then about today's session, so welcome. What will you learn today? So I actually had a lot of people, usually a friend today even, looked at me when I said, oh, I'm speaking about Kubernetes and sustainability, and they were like, huh? How are those even connected? Very valid question. People might not always think about it. So that's the first thing that you're going to learn today. You're going to see the connection between sustainability and Kubernetes. And then we're going to also run through essentially the basics of sustainable or green software development or Kubernetes use and so forth. So let's say that it's an introduction to all things sustainable and software, essentially. And Kubernetes is the main focus for today. Yeah, so agenda is looking like this. We have the introduction already underway, so we're doing really good there. And then we have the principles of green software, because we got to start from the beginning. Then we have some of the principles in practice in a microservice example. And then we're going to have a little bit of intro to Kata, which Mariam already mentioned. And then we're going to have a Kata demo there as well. And then, as always, we're going to end with some resources so that you can all go about your own sustainability journey in the future. But yeah, so people do quite often nowadays care about sustainability. Like people might think about sustainability if they try to eat vegetarian food occasionally or buy secondhand clothes or all of these kind of things. But I would say that quite often people might not think about sustainability in terms of their day job. So that is something I think that can be kind of a new thing for people to consider. Has anyone here actually, do you think about sustainability at your work ever? Okay, a few people, good. So we have a very conscious crowd, that's always great to see. But particularly, and I think in the software development and like IT industry, it's actually highly important topic. Because truly, I think this kind of surprises a lot of people usually, is that the IT industry is actually one of the most polluting or unsustainable, or one of these terms, industries that are out there. It is the same as the airline industry. So you can think about the amount that you hear people talking about, like airplane travel and whatnot, cutting down flights and so forth. But no one really is thinking like, oh, what's the environmental impact of my compute or my Netflix watching or something like that. And obviously as IT professionals, we can always kind of think about that and make conscious choices from there. And one of the root causes for this is that modern technologies require more and more compute power. So AI is a hot topic, machine learning, all of these kind of things. All of these will require more and more compute power, aka they use more resources, hence why they are less sustainable in the sense that they are using more of Earth's resources. Which is obviously, I love modern technologies, I'm here, I love Kubernetes, it's great, but there is a other side to it as well. And I obviously think the changes that the world are going through climate change are quite heavily discussed and so forth. So it's definitely a hot topic, as Mariam mentioned in KubeCon as well, precisely for this reason, because these two are actually very closely connected. And any change that we can actually do in our day jobs in the technology sector will have much greater impact than any personal choice that you have, because the scales are so different, as you can see here, and so forth. So why Kubernetes then? Why Kubernetes and sustainability? I asked that in the beginning. Well, this is from the Cloud Native Foundation's survey like a year or two ago. And I kind of like the headline here. So Kubernetes has crossed the adoption chasm to become a mainstream global technology. So Kubernetes is essentially the backbone of modern global technology. So it means that if we can nudge Kubernetes into a bit more sustainable direction, or we can use Kubernetes in a bit more sustainable way, the impact will be quite substantial. And as I said in the beginning, we might not have considered that. So Kubernetes is big, IT industry pollutes a lot, hence why we can make changes in our sphere, we can actually have a big impact. Now, if you're thinking, how to get started, how can I do things? I think, to be honest, if you think about optimization to begin with, you think about configuration best practices to begin with, not being wasteful, you're already kind of doing a sustainable green software or sustainable Kubernetes, because essentially in like the simplest form, it can be as simple as, not being wasteful with your resources. So that's always good, and you can, always, a lot of the Kubernetes best practices and configuration things apply to these cases as well. But today we're gonna kind of look into more, concrete examples as well, obviously. Now, they're going to go through the principles of green software, because in order for us to understand what is our environmental impact and what is the impact that our actions do, we need to obviously understand what is green software, or what is green or sustainable cloud usage or Kubernetes use. So there's this foundation, which is under Linux Foundation as well, which is the Green Software Foundation. Has anyone here heard about the Green Software Foundation before? Yes, there we have. Erno has heard about it. Great. So it is a foundation that is building a trusted ecosystem of people, standards, tooling, and best practices for green software specifically, and under Linux Foundation as well. So there's a lot of principles, and they are as following, essentially, like in a nutshell. It's, think about the carbon. So build applications that are carbon efficient. Electricity, build applications that are energy efficient. We're going to go through it quite fast, because you can start seeing a trend here. Carbon intensity, consume electricity with the lowest carbon intensity. Embodied carbon, build applications that are hardware efficient. So you start seeing efficient a lot here. So essentially just do that would be the simple way to say it. So energy property, so maximizing the energy efficiency of your hardware. So embodied carbon, for example, is essentially, so instead of just the compute that you use in the cloud, for example, it is the hardware that you use, the servers or the machines that you use to run it. So you have to consider that as well. And then this one is about, maximizing the efficiency of that hardware. And then we have networking, reduce the amount of data and distance it must travel across the network. And then demand shaping, build carbon-aware applications, and measurement and optimization. So focus on step-by-step optimizations that increases the overall carbon efficiency. So I'm giving you this list, and I could be just like, oh, go out and execute. But obviously, it's not that simple. This is a long list that's essentially kind of high-level things to consider. And that's why I'm going to go through the principles in practice as well. So, but this is, in a nutshell, what green software, sustainable software, usable, sustainable Kubernetes is about. And if that is too many things to just kind of throw at you at once, really the biggest impact and the biggest focus is on carbon efficiency, energy efficiency, hardware efficiency, and carbon awareness, which kind of all you can map under carbon efficiency in a nutshell. So what does, energy efficiency, carbon efficiency, what does it look like in practice? Energy, I think everyone is familiar with, particularly after recent developments in, energy discussion, energy crisis, all of these kind of words. We know things about our energy grid, for example, I think more than we used to. But it is really at the heart of everything. So if you're using compute, for example, it matters greatly on where your data center, for example, is located. So obviously Nordics, for example, have a good chunk of renewable energy and also inbuilt cooling per se with our climate and so forth. So there's a lot of these kind of benefits that help. And France is, for example, heavily using nuclear energy, which is sustainable, so there's always benefits. For example, Australia, on the other hand, has a lot of coal energy usage, so then their data centers are more polluting on that side. So energy can really be kind of clean or dirty, and focusing on energy use that is on the clean side is the key here. So that essentially means location shifting. So because the intensity of electricity and the kind of cleanness and the dirtiness of it varies by location, some grids are better than worst. Switching to a location as far as your data center and your compute that is more clean is going to have an impact already. So here is by Green Software Foundation, a map, because it's actually really difficult to find like a good illustration on different things. So you have here on slider, you can see there on the left we have more clean and then we have more dirty there. So for example, you see in US it varies by location by a lot. So if you think, oh, I'm just going to put it to US to some data center there, that will actually have quite a big impact on which of these regions you would precisely actually put your resources. I think a good example of this, and fitting for today, Google has had, for example, a project where they switch locations just locally, and they're able to cut 1% of their essentially use, and which sounds small, but if you think about the scale at where Google operates, it's pretty significant drop at the same time. And just local changes, so I'm not talking about changing, from Europe to America or something like that, but like within the town or a state and so forth. So it's actually, with just the tiny adjustments, you can actually do quite a lot. Another aspect that one can consider is time shifting. So because, as you can see here, the energy grid use varies greatly by time. So it is actually kind of funny how most people, most of energy use is actually happening in the evening. For example, when people watch primetime TV, which is also when, for example, solar power is not available. So this means that with IT, we can, for example, use shifting the time when we do things to actually impact the greenness or cleanness of our energy use quite a lot. So if you, for example, run a bad job and so forth at the time when the energy grid is really good for using it, you're gonna be quite good. For example, Windows is carbon aware, so it gives essentially a couple-hour window when it will update itself, for example, making it more better for the cleanness of the energy. So here is an example of like running software when the carbon intensity is low. So you can actually then have a great impact there. And I think another one, which I think is like these two before ones that I said are quite like you can use them for a variety of use cases because it's kind of about the infrastructure behind everything. But then you have demand shaping, which is kind of a fun one, but depends on use cases. And a good example of that is there's actually this magazine called Branch, which is a sustainable magazine, and I will actually have it here if I show it. So this is how it looks like right now. So we have grid intensity view, so it's live, so it updates accordingly. So we can see that it is in grayscale, the pictures, so we're using a bit less, and we can actually click here, and we can click if the grid intensity is low, we get color, because we can actually use more of the resources. So we have color, we have more vibrancy and so forth. And if we click to moderate, we go to the grayscale, which we had before in the live view. And if we go to high, all of the images will just go away. And now this is obviously like, not everyone can run a sustainability magazine where they don't show pictures all the time, but it's an example of things that you can like think about and consider while you're making changes. But that is demand shifting essentially. And then let's navigate our way back to here, perfect. And obviously increasing utilization is a big one as well. It's not always possible, but if you're like maximizing your utilization of your hardware, this is really good, and key area where Kubernetes itself can really help and have an impact. Now, usually at this point, people are like wondering, okay, well, it's really important to like think about these things, that's really cool, but how do we actually calculate, am I good or bad? Like, is my software, for example, doing well or just doing badly? Well, Green Software Foundation has done software carbon intensity, a CI, like calculator specification. And I'm not gonna go deep into it because it's quite of a long thing to discuss through, but you can deep dive into it in their GitHub page where they, because it's an open source foundation, they really talk you through like, well, how exactly is it calculated, how can you do it, and so forth. So we have a way, and obviously, since sustainable and green software is a rather new topic, and it's constantly evolving, I would say that anytime I do this session or this topic like sustainability and green software, I have to do like multiple hours of research because everything is moving forward so fast. So, but they always have the most up-to-date information, for example, in the GitHub there. But it's kind of being trickled upon constantly because it's a new topic. But that's great, isn't it? That we're kind of moving further and progressing as we go on. I'm not going to focus on the principles of green software in practice today because this session I originally built it for a 1 hour session and we have 30 minutes today. But just kind of like quickly to give you an overview on some of the things that you could be doing when you're managing microservices. So for example, you can optimize network traffic, you can increase your compute utilization, reduce your number of microservices, optimize your database, understand your latency limitations, and so forth. So this is like this is a checklist that you can kind of run through if you're looking to do this. And Green Software Foundation, for example, has a lot of these resources available, so you can kind of go through their checklist as well, and they're constantly building more. And for example, for optimize your network traffic, we can kind of explore what's in there. So you can think about like your traffic and your architecture, so reducing the amount of traffic your architecture creates per operation, as well as the distance each request and response travels. Then using caching headers, so for example, is a good one as well. And considering using a CDN, so content delivery network, to distribute your application's static assets closer to the source of the request, because this reduces the distance all requests for static assets has to travel over the network. So reducing the size and optimizing your bundles and static assets as well, whenever possible, and then using compression and decompression for your data so that it takes overall less energy usually if you do it this way. So these are the type of things that you can then do, and obviously it depends on your exact situation on which one of these you need to use and so forth, but some examples there. And then we have also increasing your compute utilization. I think I'm gonna not focus here, but like you can, using auto scaling or burst capabilities is here, using smaller virtual machines. And I think the fun one actually is, which is quite easy, is using platform as a service whenever possible, because usually for platform as a service products, the thinking is kind of done already there. So the solutions are sized appropriately for their workload. So that's like an easy, cheap way of doing already good impact. And so forth. And then reducing the number of services as well. So microservices architecture in itself is already really good. And using regions with lower carbon intensity, which we already discussed. And then we have use languages and technology stacks that optimize the efficiency of specific microservices functions, which is fun one, which leads me to this, which went quite viral at some point. So who has seen this sort of energy efficiency across programming languages? Yes, I always hear this, like no one has heard about Green Software Foundation, but this one, because it's such a nice one. It's like, you can check your own language and how bad is it or good is it. So it is a lot of fun. But with this one, for example, some of the findings you can, like I've highlighted here. So you see like Perl and Python is there at the end, and Rust and somewhat is in the big bottom. But obviously this isn't as clean cut as, you know, a viral headline is at the same time, because when you, for example, then consider the energy usage versus, you know, time and memory and so forth, we can see that then the list changes a bit. So for example, Python, that is at the bottom of the other one, kind of moves actually to the better quadrant of the other one. So it's always a bit of a, it's not as clean cut as, oh, everyone just now, you know, start developing Rust, for example, even though it's okay, you can go ahead if you want. Yeah, but also, I think a good thing to remember, which I think most of the green software practitioners also talk about, is the fact that even if you were to, you know, use Rust, for example, if you write really, really bad, really unoptimized Rust, for example, or any of these other ones, you probably will do worse than if you use really, really efficiently some of the other languages. So if someone here is, you know, bummed that, oh, they, you know, focused on Ruby or something, no need to worry. If you do your work really well, you can be fine. You don't have to switch careers or something like that, or learn something completely. You can do a lot of things with any of these languages for sure. But yeah, and then we have optimizing your database as well. So using your database well, ensuring you're using the best database for interacting with your data set as well, indexing as well if your database offers it, evaluating and optimizing your queries, as well as using database cache. And then we have understand your latency limits. I'm going to run through because we have 7 minutes left and I still have to go through the demo. But essentially here you can, okay, but it's fine. But you can see here that it starts to get a bit repetitive at the same time, because you can see here the worker processes in regions with less carbon intensity as well. So it's like these basic things that I already kind of mentioned in the beginning really take you quite far. And I really like the beginning one as well. So think about what you actually need for your application. I think the software industry has been pretty much in a mindset of, you know, oh, fastest is always the best. You know, you always have to be always available immediately and so forth. And sure, for a lot of cases, yes. And I'm definitely not saying that don't do that if your application needs it. For sure, keep that in mind. But actually, not every single application needs to be the fastest ever, for example. So you can kind of think about these things in that way as well. And then we are going to the auto-scaling part, which is the Kata part. So Miriam already mentioned it before. So Kata is about the fact that default Kubernetes scaling is not really well suited for event-driven applications. And Kata then is event-driven scale controlling that can run inside any Kubernetes cluster, and it can monitor the rate of events to preemptively act before CPU is affected. So you now might be getting the picture of why am I here talking about Kata. So essentially now we went through like, okay, high level, what should you be doing, what are the kind of rules and things that are happening around green software, and Kata is a great example of a project that you can use then to supercharge or whatnot your green software journey, which is that Kata is a CNCF project in the incubating phase, but aiming for the graduated phase as well. You can install Kata into your existing clusters, and it has 30 plus built-in scalars, and you can build your own. And as Miriam mentioned, and I have a note about it later on as well, they actually just in KubeCon released a carbon-aware scalar as well. So now you can actually, you know, scale with carbon-aware in mind. Before you could just, you know, do auto-scaling in general. So I have a demo here, which is scaling a .NET Core worker with Azure Service Bus. And this is how the demo essentially looks like in a nutshell. So where we have the order portal, order processor, order queue, and order generator, and so forth. But essentially, we can imagine this demo as a web shop that gets a bunch of orders at the same time, whether that be, you know, Eurovision is coming up. If they have, you know, Eurovision merch or something, they really need to be prepared for that peak in orders there. And now let's go here, and this is gonna be extra fun with a handheld mic as well as like looking here. So bear with me while I figure this out, but it's all right. We're gonna do great. So let's do here. So we're gonna do kubectl gets everything. Okay, I might have to. Let's see how it looks like. Okay, we should get the external there. Oh, it's fine. Or actually, yeah, let's do. There we go. I think it looks a bit better now. We can actually see something. There we go. Then let's see here. This might take some work. Let's see how it looks like. Yeah. So here we're getting some visibility. Oh, that's perfectly done. So we have the order queue length here. So we will here see the peak of orders coming in. And then we're gonna get some more visibility. So we have kubectl get deployments here. There we go. So in here we see the order processors, how many of them are ready at any given time. And then we have kubectl get pods here, where we'll then see the status of all of those order processors. And then we're actually gonna get to the fun part. This has all been just setting up the demo. So if I see my cursor, there we go. So here we go, .NET Run project there. So we're gonna see now, let's queue some orders. How many do you want? So these are all of the carrier short orders that are gonna come rushing in before Eurovision. So how many do we want? Can someone give me a number between 100 and 150?
142.
142, I heard at least. 142. Is that correct? Perfect. Let's queue some orders. So there's a chair for Chris. There's a pizza, chicken, computer, cheese. It's going fast. Pants, all of the orders are coming in. And then we see the order queue peaking there. It's getting closer there to 50 to 100. And soon we should see Kada jumping in to get all of those order processors working. If the internet is working very well. Let's see, now we're getting closer to 150. There we go. Few of the demo issues, if it's all working nicely. Order processors, 4 out of 4. We have it's pending, container creating, and it's starting to go to the running phase as well. And we see that it peaked at the 142 mark, close to the 150, and now it's starting to go down because data, as you can see, kicked off, and we have the order processor coming in. So we have 8 out of 8 there, and we're moving from there from creating to running more, and we can see the order queue being handled. And I think it might go up to 10 out of 10. It usually goes, yes. So we have order processors 10 out of 10 in use. And then we are switching more and more from creating new to the running phase. And as you can see, the order queue is starting to be at the end there. So that is exactly what Kada does and the magic of Kada there. And now, in about 5 minutes or so, or a bit less, Kada is going to start actually auto scaling them down, because that obviously is the crucial part for environmental friendliness, not to use resources when you have spun them up. But I'm not going to wait for that, because as I said, it takes a few minutes. So we're not going to just sit here and look at this for 5 minutes. So we can move on. But that is the Kada demo. Now, Mariam already mentioned this. I think this is the session, or it was another one that you mentioned, but on the same topic. But if you want to learn more about the kind of carbon-aware cloud and carbon-aware scalars, this session, for example, talks about it through, or check out all the resources that Mariam shared as well. Okay, perfect. This is the correct one. So then another great resource that I think is super helpful is that relatively recently, so as you can see there, May 31st of 2022, CNCF First Environmental Sustainability Working Group was established. So they are doing amazing work as well. There's a lot going on. They are relatively new, so they are getting started. But more important is to actually get involved there as well. So they have a Slack channel that you can join in the CNCF Slack. And start contributing there as well. Or if you don't want to contribute, they actually are super friendly. And if you have any questions about green Kubernetes environmental sustainability, they will answer. Or I'm in the chat in the Slack as well, by the way, so anyone can answer there as well. And they have working like office hours and everything, so you can get involved there. They're building, for example, a Kubernetes best practices list from like NCF essentially. It will eventually become as well, but that is not ready yet, so unfortunately I can't show it. But as I said, everyone can start contributing to there and working together with those as well, or wait for the best practices from them as well if you're so inclined. There's a lot of great projects as well. So there's GreenCube as well, which is a project that focuses on spinning down deployments during hours when they're not being used, and so forth. So it's a simple Kubernetes add-on that automatically shuts down some of your resources when you don't need them, for example. And then there's gazillion other ones as well, but first off, KubeCon also has a calculator as well, so CO2 calculator where you can put in your pods per year and total number of pods as well, and then you get some numbers out of there. And there's so many projects more. So there's Kepler, for example, which uses EPBF to probe energy-related system stats and exports its Prometheus metrics. The carbon-aware scaling is now moved to actually being available. And there's a lot, and Green Software Foundation has a carbon-aware SDK as well. So there's a lot of things going on, but these are like constantly being updated and new ones are being added. It's great time to be working in this space. And now most of the, or all of the like major cloud providers also have like transparency into their carbon impact of your cloud usage. So this one is, I think, from Microsoft, and this one is from the Google side, so you can actually calculate your carbon footprint with like resources from your own cloud provider as well, which is usually quite great as well. So now we're nearing the end. There's some resources sharing there already, but as a reminder, if all of this seems too overwhelming, I'm hoping it didn't, but if it did, you can also just use best practices from multitude of fields. So just as I said in the beginning, all configuration best practices usually help. You know, cost optimization usually doesn't hurt. The like sustainability optimization either. So you can definitely kind of take a lot from other sides as well. And now, if you're wondering, okay, this all sounds really great. I want to be sustainable, all good. But how does it impact then my like business bottom line or so forth? Well, actually, usually if organizations do sustainability optimization and so forth, it actually leads to organizational improvements because you really have to think about your setup and why are you using the things that you use and so forth. It usually leads to improved performance as well as to cost savings. So I like to stress that these things don't, like, you know, you don't have to be like, ooh, now I want to, you know, save the planet and become completely green. You can actually do these things together with business goals and work hand in hand with these. But obviously, it will definitely help with your sustainability goals. And then the saving the world isn't too bad either, you know, it's a nice bonus. But as a wrap up, we went through introduction, we went through principles of green software and principles in practice. Quickly there, we went through the Cater project as well as a demo. And then we went through resources as well. Actually, we could check if the Cater demo did like finished by this time. Yes, we have the order processor 0 and terminating all the way here. Not as exciting as the main part of the demo, but even more important, I think. Then we can switch back here. If it does, okay, let's go there. But all of these materials, I will add them to my GitHub, so you can find all the slides from there. And then in that slide set, I've included like a bunch of these links. So Green Software Foundation has so many things. So there's a podcast, blog, YouTube, a lot of upcoming projects and everything, so forth. And the CNCF Environmental Sustainability Tag or Working Group has a lot of upcoming projects as mentioned before. And they also did a session in KubeCon called How to Get Involved with CNCF Environmental Sustainability Tag, which is like Working Group tag. So if you're interested, check out that. And then the Slack is linked there, as well as their high-level project overview, as well as the best practices working doc that they're working on. But as I said, not finished yet, so you have to wait a bit until you can find the full document there. And then there's also a lot of like different lightning talks done in KubeCon and whatnot that you can always check out. So there's a lot of things to help you get started. But I think as a conclusion, any activity that you can do to optimize performance is putting you in the right direction. So that's a good place to start. But if you can want to deep dive, you can follow the deeper guidance and then, you know, get to that saving the world part eventually. But yeah, thank you. And I think could we have a break? Yeah, a break, and then
15 minutes
Nicholas
or
is
something
gonna
like
come
that.
in.
Yes.
Yeah.
So today I'm going to share you some lessons learned during a very long journey of xCloud. I've been working with xCloud now since 2017. We went with Kubernetes 2017. We went into production, and that's so now it's like a 6-year journey of Kubernetes that I want to share. A few topics. I cannot definitely share everything with you, but I will share 2 things. If you start with the context, so when you speak xCloud, it means so different things to many people. That for us in this talk, this is going to be an on-premise box or multiple boxes, but a small Kubernetes cluster, extremely small. It's going to be like really the smallest thing that you can run on site. And our scale, what we designed for, is something like 10K Kubernetes clusters. So we really go into that. Treat your clusters as cattle, not pets. We cannot really have people that sits and watches for 10,000 clusters. It's also self-managed. So when we go, this is an on-prem edge, which means that it's not on-prem in our facilities, but it's on other companies' facilities. So a very good example is harbors. So if you take, in Finland we have the Kotka harbor, which is a fairly big harbor. They have an edge cloud on site, and then they have different use cases to run workloads on top of that cloud to manage their operation of the port. That is a very common use case, why we have this on the site. It's self-managed, and the reason there is, if you again go to the Kotka harbor and look at their staff, there are kind of very few Kubernetes engineers in their payroll. So our solution is fully managed, and that means that the solution is going to be so that it's automation only, and if it's not automated, we don't do anything for that. It can't be that cost effective. Is we want to scale this as good as possible to as many as possible. The expectation is that there is something 10 million industrial sites in the world, so 10K of that is something 0.1% is our kind of design target. When we go to the stack, everyone when you start to talk about edge cloud, they always ask, do you run Ubuntu Snap, do you run RKA and whatever. Our stack is this one. We have the compute, we have TOWS as the operating system, containerd and CLI for managing the containers, and Kube with an XD runs as separate servers, and then vanilla Kubernetes, and then our applications top. We come from a CoreOS history. We had a good experience with CoreOS, I would say, but it was also a horrible transformation from CoreOS when CoreOS went into the Red Hat path, the IBM path. Those who know the story know that real that wasn't that clean. Our target here is that it's immutable. It's really, we want that our operating system, no one touches it. So we don't want the shell. If you haven't looked in the TOWS operating system, there is no shell in this one. We have only an API. It's a Kubernetes operating system only. We can only run Kubernetes on top of this, nothing else. So then we have the OS lifecycle. When you are at the edge cloud and you're remote, you don't necessarily have physical access. One good example is if you go to Antarctica, we have one case there, and there's 3-month lead time for someone to go onto the site, so you can't really have someone that needs to touch the box. So that has really been our design target, that it has to recover from any kind of situation, and the life cycle has to be self-upgradable all the way to the operating system. That's the main reason why we have this operating system, for simplicity at scale. I just wanted to show this. This is actually not what we are going to focus on today, but this is really what people ask when you do edge cloud. So here you have, like, this is the operating system. You have trustd, UDD, and then you have APID and machined. That is the whole operating system. There's nothing else. Then you have kubelet, etcd you need for Kubernetes, and then CLI and containerd for managing your containers. But then let's focus on our learnings of the edge cloud. So when you go into a customer premise in the enterprise world, they have different kind of workloads really that they want to. If you take the hardware example again, they might have cameras that serve for surveillance, but then they might also have automated straddle carriers that actually moves containers around in the harbor. They definitely don't want that a push-to-talk device, for example, people carrying a phone can reach the network of managing the straddle carriers. Therefore, we need to have isolated networks. That in principle means VLANs. And when you talk about that, you know the drill. There is nothing as such in Kubernetes. So then we go into the big problem of Kubernetes, which is CNI. CNI is the only resource left in Kubernetes that is single by nature. If you think everything else, you can have multiple pods, you can have multiple CSIs, you can have everything in multiples. But CNI is the only one that you can have only one. And how that looks like is you have your overlay network, you have some kind of CNI plugin, a bunch of these exist. In our case, we use Calico, which is probably noticeable, not from this picture, but yeah, we use Calico. And you get the single interface, single IP, everything is good for cloud workloads. But then when we want VLANs into the picture, it gets slightly more complicated. So now we go into the hacked solution, what the community has come up with, which is network attachment definitions. And that is a way to telling that when kubelet spawns new pod, we have de facto multus, which is a meta CNI plugin, which just spawns other CNI plugins. And this one can then spawn call multiple CNI plugins, and then we can get that one port with annotations. You can get two networks attached into the port. You might think that everything is super happy and good, so now you can have one separated Ethernet interface physical here, and you separate that with MAC-VIL and SRIOV, whatever your underlying network technology will be. For telco workloads, that works certainly very good when you are kind of aware of multiple networks. So we have a port there. We kind of ask for, yeah, I want two interfaces, and then you will kind of have inside your port, you will have one ETH0, which is your overlay network, and then you have the other network interface, which is here attached to a different network. This unfortunately brings a huge problem into your applications if your applications are not multi-NIC aware, because then they need to become routing aware applications as well. If traffic comes in on this, they need to know where to bind their sockets and also how to route the traffic out of the port. So then we go into our solution, which is kind of an implementation of the SIG Networks multi-NIC solution, which is an ongoing thing in the Kubernetes community. It's going to be a thing in Kubernetes to have multi-NICs. We are already there with that one. This is how we solved it. So now we go into a slightly more complex scenario actually. We have still our same data port, which is VLAN segregated on top here. Then we bring that one in to something that we call vRouter over here. That is the pool port. In here, as we love Kubernetes, what we do is we run our own Kubernetes inside a port to isolate the things. So we have, on the outside, we have the normal Kubernetes, and then we run inside this port, we run another Kubernetes etcd and API server to do so that this network doesn't have any relation to the overlay network, but we still have an API server and etcd, and then we have a sync service over here, so that we sync any kind of services to this inner Kubernetes. What that gives us is that when we have the application network over here, we can deploy our ports normally as they would be. So these are deployed normally on Kubernetes, but we are attaching them only to this app network over here. That is a separate network attachment definition. And when we have that one, we will then have single network interface in these ports, which means that these doesn't have to be routing aware. But they will still have the Kubernetes experience. That's the most important thing here. We still want, because these still talk to the API server if they want to do things with look for services or even create services or create new ports. So what we do is we pipe to a point-to-point link, we pipe that out so that we can reach the API server from these ports. And with that solution, we can segregate it. Now we can take in third-party workloads that creates new ports through operators, and they are totally segregated network-wise. So they are in a VLAN segregated namespace from the networking point of view. We will have a short demo of that in a while, and let's hope that it gets more clear. This is certainly something that is a neat way how you can actually use the Kubernetes API to something more than just running the Kubernetes API. And to glue this together, so now we have those distributed edge clouds running in the field. We also need to get their configuration somehow configured, because every site is different. So we need some kind of configuration per cloud to be configured. As I said, we started 2017. That was Kubernetes 1.7 we went into live with. There are people here, there actually existed something when the custom resources was not a thing in Kubernetes. So we then start with the solution, okay, we need to still configure something to those edge clouds, so we have these clients over here, and then what we built was we just do a bidirectional gRPC stream between a server and the client, keep this one always open, so that clients and servers, they can talk to each other over normal gRPC however they want. What this brings is that, I mean, the server has some database over here, we need to migrate those, we build new features, etc. Same thing, we take the data from the database, pipe it over a gRPC API, and then these clients need to also work with the gRPC data and store it also locally somehow. So this was actually one of the biggest pain points we had in our early journey when we started with our edge cloud solution. Then we came out with somewhere around 2018, I think it started, that the Red Hat friends came up with the operator framework, and we started to embrace that. We still keep our gRPC stream, which we had developed, but we started to migrate. We didn't run any database on the clouds itself because we already run Kubernetes, so why not store to custom resources and kind of utilize that solution. Worked pretty well. I mean, everything is good with custom resources, so no problem there. But we still have the problem that we know. We still have a database in our central cloud, and we need to write these servers and write the gRPC APIs and transfer data back and forth. So as we love the Kubernetes API, we figured, why not make a digital twin solution out of the Kubernetes API? So now we have our central cloud over here. We have the API server that manage the whole Kubernetes solution. But then inside the new namespace, we do the same. We run an API server, control manager, and etcd. And then we pipe in our custom resource definitions there. And we let our servers, so these owners, they work on custom resources instead. What that gives us is that we can have our front-end UI code to actually work on the open API schemas that comes out of these custom resource definitions. So we don't need to do any boilerplate like conversion between taking UI code, storing in database. Now we instead use Kubernetes directly. We store everything as custom resources, let the API server serve the open APIs to our UI, and then we configure it there, and then we just implemented a kind of a syncer over here, which just do the create, update, delete of those CRs. So these are then one-to-one mapping from the cloud side and to the edge side. So now we have instead a solution where you can do clients work as normal Kubernetes operators, everything is good, and they just get the data configured by a user over here in the UI, and then we store the custom resources, and those are then out of sync in real time. So when this triggers over here, this syncer is just having an operator that watches everything in our resources that we look for, and if it finds someone, it just pipes it out to the right edge cloud with kind of metadata only that we know which one should get this one. So let's see if we can see this one in a demo. If you can help me, Lucas, that would be all right. So what we see over here is, let's go in there first.
Oh yes. VPN. Perfect.
So now we are in this, the upper window is the cloud side, so where we store those. So if we see how we have divided this, is we have a lot of these namespaces that are like strange named. And what that means is we have divided per customer, that one namespace is one customer. So what I'm now doing, I'm just going to look in my namespace that I have 3 of these app site network types. Then we go into our UI and look for the same thing over here, which is application networks. I see 3 of these. And if I open up this one, this is the configuration over here. And this is just an OpenAPI schema that we take directly from the OpenAPI of the CRD. So let's, yeah, I'm not allowed to do that. Let's try to create a new one and see how, well, let's first look on the edge side also. So this is now one edge cloud. How we have divided here, we see 3 app networks, so these correspond to these app like site networks, and if I change to one of these ones, just to not show too much proprietary, so then I do a kubectl app site network, and we have something like E1, and we should see something like E1 over here also. So this one is now one-to-one kind of from the cloud side and on the edge side. So, I mean, how this one then goes is we just create a new network. We don't care what we create. And I already have V1 360 views, so let's change that to something else.
Nice to see that the animation controller actually is working.
Exactly. Right, so now we got a network created. If we go on the cloud side, we should see we got one new network created, and over here we should have then seen a new namespace over here get created. Let's go on to that one. So what we see that here, now we go into that one. Now we have our vRouter, what I showed you there, and how we automate this whole. So we have the attached def. So we have now those 2 networks. We have one that goes out, transit, which goes down to the physical hardware. So that is the VLAN, what I created. So we see that we have a VLAN 36 over here, what I created, and it maps to the physical ETH4 interface. Let's go ahead and say that, okay, I figure out VLAN 36 was not the way this was supposed to be. So then we should have somewhere the VLAN. Let's say we want 364 instead, and what then happens is this one should start terminating, as now we changed the network, so the port that was running was attached to a VLAN 36, but now when we got the new configuration, this one should now have a VLAN instead, and now it was 364. And then when we look at that one, on the network attachment definition, that should also have changed to 364. So therefore we needed to recreate a port to get that networking actually provisioned on the physical network as well. Good. Let's give a very brief about how that application networking is. So now we focus only on this edge side. Now we got the network created. So now I'm going to simulate that we have someone deploying applications. And we just deploy an NGNX over here. So we got the NGNX created. I'm going to change my namespace to apptest, which this one. We created a new NGNX. And how this now looks inside that one. So this is now attached to the network, the internal transit. And if you see now, let's do this one instead. So we see that we have only one interface, but this is certainly not the overlay network. This is now the internal transit. And if I want to do a lookup, let's do console that we have running. That wouldn't kind of work anyway because this is now isolated. It has the DNS server is configured into the pod that it uses the vRouter, which I showed that we had the whole control plane running. So core DNS is running on this address, not on the overlay. So for example, if the operator now that operates this creates a service also. So if you look on that one, it's just a simple service, maps to the test and the HTTP 80 port, so the NGINX port. If we now do the same, I should have showed that before also. So we can do NS lookup on the app. That would show us that we have an address which is rather interesting. And this is now how we do it is because we run inside that control plane, as we run a full Kubernetes control plane, which means we also run a queue proxy. So we also have an IPVS-like mapping that this is the internal overlay, so to say, of the internal pod. And this one then maps. When this one is looking in this kind of network for that app, it will show this address. And that is then in the vRouter itself, it maps to the normal queue proxy that it goes to this one. So I can then do and I get the NGNX just to verify that it can also deploy another pod into the same namespace. So it's just a normal Alpine container. It's running. And we can do, Alpine is not having curl, so let's do wget. And we get the index in.
I
So
remember right.
that's kind of what I wanted to show about the demo. I hope that it gave kind of how powerful the Kubernetes control plane can be if you just figure out that it's so much more that you don't have to do it for just scheduling your workloads. The last thing I wanted to share with you is what comes next. So certainly this has not been easy to get these. I mean, when we start to do custom resources for everything. It has shown its weakness with the Kubernetes custom resources as well. Kubernetes has this north-south, like parent-child relations are extremely well defined. You have the owner references kind of working. Second is the storage versions. I mean, when we have the edge clouds in a distributed fleet, if we start to bump the API version, as Kubernetes has only this, you can only have one storage version for your custom resources, which means that our central cloud can only have one version, but our whole edge fleet could simply be on different versions depending on when they do their upgrades of their own custom resources. So it's not very suitable for that, so that's why we have come to the conclusion we never do breaking API version changes. If we need to do something, we actually do a new custom resource instead. That's the way we have solved that. It's not super like good solution, but it works for the intention that we have it. We can easily extend our APIs for that. It worked well, but then migrations between APIs that actually needs migrations has been difficult. As I said, we have split per namespace per customer. We can certainly do other splits as well. For us, that has helped us in do the efficient searching, as Kubernetes is not like a database that you can do select like that, but it's easy now when we have a namespace for customers. We find everything for a customer in one namespace. But then the real problem we have is the siblings problem, and I really would like to give a shout out that someone come and tell me how to do this, because we haven't figured it out yet. So what happens is that we had an application that is the owner, then we have an application configuration that is a child of that, so there's an owner reference to the application. So that solution is very good. I mean, if you delete the application, you will implicitly also delete this one. That's the way Kubernetes works with these owner references. But what about these sibling relations? So now you have another, in our case, we have the network, and we attach the network to the application configuration. And that causes the problem that we now need to link these together, but there's no such thing existing in Kubernetes API that you could do that. So we have been doing like custom code for like putting the reference over here and maintaining those references. That's the challenge we have. We hope to do cross-plane for this, and that's what I want you to show me as the next meetup talk.
No pressure.
No pressure, but that's what I want you. We have been looking into it, and I hope really that we could do an easy kind of cross-plane solution, that we would just somehow magically glue these siblings together without causing too much extra overhead working.
So what can you expand on what would you need from the siblings? Like what should happen when you do different things?
Yeah, so we can, when we have this relation, if this application configuration is already bound, that means that we should prevent that no one can go and delete the network because we are using that one. But now, from Kubernetes perspective, it's totally fine to delete this one because there's no owner reference here. So just delete that one, because this is a loose coupling. Just because there's a field that has a reference in the spec field doesn't prevent someone from deleting this one. You need to have like admission controllers that actually prevents you from doing that.
I think, can't you do block all if you make a network owner reference on the network and then block owner deletion?
You mean we don't want these to be owners of that. They are not owners. These have actually, in the real implementation, there are other owners of these. So that it's maybe a bit too simple example, but this one relates to something else also in the north-south direction.
Yeah.
But it's a shout out to the community that please show how to do that, because I haven't really found a good way to do it. And the second thing is with what we try to kind of solve with crossplane is really when we do everything with these custom resources. So when everything is glued to one edge cloud in the field, to have every custom resource synced one by one is kind of causes challenging in error scenarios and so on. So with crossplane we kind of would like to go into that. We would call out to some API in the cloud that gets a whole bunch of things that would be glued together and put some crossplane into doing the syncing for us to get rid of our custom syncing code. That's something that we are looking into, and that's the next step.
That's a question.
Yeah.
Like, what if you create like an independent API that links the syncing code to all the particular to all the particular containers?
Right. That's exactly what we would like to do with crossplane, to actually have that we link that with the crossplane. We don't want to write custom code for that. We would like it to be automatically that we would have a crossplane API to really, like, when we add something, it just gets added as a kind of relation to that API, that you have one edge cloud as one main resource in crossplane, and then you can just add into that crossplane section that now we have those references also. That's what we try to achieve, but we don't have anything working for that yet. All right, thanks.
Was there any other questions? Okay, that's cool. Yeah, are we putting the stream together or?
Yeah. Thanks, Nicholas. So next up, I will put on the stream running here. We will soon get some popcorn in here. The pre-show is already running there. I don't know what's going on in there. And I have no clue like what they are going to announce today. I tried to find out some tips, but couldn't get anything. So it's really exciting what there's going to be new announcements. Probably, of course, something Gen AI and LLM, and maybe something new in the Android ecosystem. Meanwhile, my colleague Jussi is somewhere here. Where did he go? Disappeared. Oh, there. He can also help with me. And of course, Nico from the GDG. And I will actually, because we are out of drinks, I will run to the closest K-market and get some drinks. So hands up who wants beer, non-alcoholic beer, even more hands. Wow, what is this? Cider, sodas like Coke, couple of hands. So pretty much everything. Any Lonkero drinkers here? No, that's good. All right, but let's put the stream on. There's going to be popcorn. I'll be back with the drinks in, I don't know, 20 minutes maximum. Thanks.